Olaf Zielke, and what you're watching here is the first of a number of YouTube videos that I will produce in order to provide some documentation for MCQSIM version 2. MCQSIM itself is a program to generate synthetic earthquake catalogs that can be used in different ways, such as parameter space investigations or for seismic hazard assessment. A previous version, version 1, of it was published last year in BSSA, as you can see here for reference. The actual code for MCQSIM will be hosted or is hosted on GitHub. You can see the address right over here. And if you want to contact me for collaboration, feedback or suggestions, please use my email right here. Okay, so what I want to do with this very first video is just give a quick overview of MCQSIM, how it's organized. And then later on I will go into other videos where I will share the workflow, really. So, okay, let's get started. Just as an overview, here you can see that MCQSIM itself is basically contains 3 different components. First, the pre-simulation part, which is where you define the input parameters, fault geometries, etc. Then you can run the actual simulation, and then later, as a last step, you have post-simulation output. So just briefly going over these different GUIs in that case, what you will see is, as it says here, input and output are organized in MATLAB-based GUIs, in graphical user interfaces. The main code itself is a C code. It's parallelized with MPI, and it runs on HPCs as well as other multi-processor units. So when it comes to the input, there are different components to it, and here you can see how they are labeled and organized at this moment. In the first step, you have different GUIs or MATLAB applications, as they are called these days, starting with an A1, A2 and A3, and they all do essentially the same thing, and that is defining the geometry of the faults that you want to run earthquake simulations on, and then also meshing these geometries. In the next step we have the GUI called, it starts with a B, in which you can define other fault geometry parameters, for example adding or superposing some rough fault geometry, some self-affine or self-similar fault roughness, and you can also define the strength and friction parameters for the fault and its fault elements. In the next step we have a GUI that it's called, it starts with a C here, and this one is essentially just a helper to create a text file and an SH file containing parameter files to run the actual code. And then we have the simulations, and I will go over this in a later step, as well as then the outputs. And then for the outputs, there's again some logical order to this. We have all the outputs can be viewed with different GUIs, starting with a Z, and this number behind it kind of refers to different levels of catalog, in the sense that not every catalog contains the same information. You can specify in a pre-simulation setup what kind of catalog detail you want, and then you have different outputs or output GUIs to view these different files. Okay, so I think this is it for that specific video, and I will in the next video start to explain the different GUIs, starting with A1 and then going through the different ones all the way. Alright, thank you.